Yo, welcome back. Another day, another episode. Yesterday, I started off the video with I didn't really sleep that much. I whipped out the caffeine pills. I guess everybody's a sleep doctor all of a sudden in the comments. All good though. Oh, I have it flipped. I didn't realize. I got to make the Pokemon sound of the day. Shout out GitHub followers. We appreciate that. I'm coming up really soon on my interview, and I'm kind of thinking maybe I kind of let off the project until the interview's over, and go from there. We'll see. All right, Pokemon sound of the day. Okay. I have a company list too, but let me just see the daily problem. Maybe this is seeming kind of hard, bro. Find the maximum subarray sum of all the subarrays of gnomes. How is this a medium? Am I tripping? Okay, well, I'm just gonna have a Is it at least K or of K? It is K. Okay, I can do this then. Let's just do a quick warm up here. Hopefully this problem is easier or as easy as I think it is. For I enumerate nums. Okay. We need an L pointer. This is an R. Do R. L equals 0. If while L or R minus L plus 1 is greater than K. And L is less than. I don't think I'm going to need this, but I'll just put that in there. All right, let's just make sure that's working. So for I in range L to R plus 1 prints. Oh, it's going to do it on different lines, dude. How to make Python print on same. There it is. End. There it is. Oops. Print gnomes at spot. I want to do boom. I'm gonna do it with some class, bro. Oh wait, that's not gonna work. Okay, never mind. Gnomes at spot I and equals a space. So this should print all subarrays in the thing. They should print all of these here. Oh shit. Oops. Bro, what? I didn't even run it that fast. 5-4, 5-4-2, 4-2-9, 2-9. Easy, bro. Do I wait? when I get the greatest sum. Okay. Negative inf. All right. And then I do if num not in hashy at spot num equals 1. Do I have to loop? Do I set a flag then? I guess. So I'm going to do a dupes flag so I don't have to. Okay. I just realized I thought this was going to be easier than I think, right? So basically, guys, we have the basic structure set up to get every single subarray, right? We have 154, 542, all these wonderful subarrays of size k. And the trick to this problem is this duplicate part, because the problem is that there's a potential n squared opportunity here where after every single subarray, I do I check like if there's a duplicate in the array. That should be an O1 check, okay? If it's not an O1 check, it's going to be, the runtime is going to be too long. It's going to be n squared in the worst case, because k could be the size of the array, and then we have problems. I think. Something like that, all right? Point is, it's bad, all right? Or I guess it's n times k, maybe? I don't know. So yeah, so we're going to want to do that. We're just going to want this to be O of n. That's it. We're going to want to loop through this once and call it a day. So we're going to have this dupes clause here. So if num not in, or if, or else, hashy at spot num, that's funny, plus equals 1. Now, the way we're going to keep track of this dupes thing, we're going to put this outside first here, is when we do this, we're going to want to delete hashy at spot nums at spot L minus equals 1. If hashy at spot nums at spot L is equal to 0, we want to delete hashy at spot nums at spot L, I think. Wow, what am I doing? Yeah. That's fun, that's fun. And now we need to check. See, like the dupes thing would be true right here. Because there's 2, because we're about to do the check. See, that creates a problem. So what if there's multiple? Oh, wait, no, the hash map needs to be of size k. This is stupid. What am I doing? I don't need any of this. Right, so if len of hashy is equal to k, no. How do I do this? Wait, hold on. Oh, and this needs to be 0. It's not, it's, god dang it. Cur, we'll just do a cur equals 0 here, and then cur plus equals num. And then over here we'll do cur minus equals nums at spot L. And so instead of this, we have cur, and then we should just be able to return res, and it just kind of works here. But I don't know. Kind of just coded this up. I'm not really entirely sure. Oh. And that's why I'm a competitive programming genius, everyone. Like and subscribe. I'm the best coder ever. If I don't get this interview, by the way, guys, if I fail this job interview, bad things will happen. That was easy. That was really easy. I'm not gonna lie. Easy sliding window problem. Can appreciate that always. I'm surprised I got 22%, even though I think this is the fastest way to do it, because this is a pure O event solution. Maybe minus this deletion. I'm not entirely sure how this deletion works, or like adding to a hash map, but no, because it's, I don't know. It's n squared if I have to. I don't think deleting is n squared though, or is n. All right, anyway, I'll be back. All right, I'm back. So I'm just gonna go down the list. There's 12 questions. I've done most of them, but these are on the list, so we're just gonna wanna, get to it. This one low-key tricky though. All right, so we need to make the array, or not the array, the hash map. Romans. Okay, we got I. No, I want to do it in opposite order. I want to do M. I guess it doesn't matter because it's a map. They're unordered pairs or whatever. Okay, nice. And yeah, so what we're gonna want to do, guys, basically, if the number is not a 4 or 9, we're just gonna want to do a simple. Oh wait, no, this is an array because I have a 2-pointer. I'm gonna do a 2-pointer approach where I start here. Or P, I'll just call it P for now. Basically, we're going to start here, and we're going to keep moving this. We're only going to shift this pointer to the right if this value, we start at m equals 1,000, is smaller than our current value. So, for example, let's take a look at num here. We have 3,000. Let's take a look at num here, right? So our current number is 3,400 or 749, right? And we're going to want to pay attention is the, and our M is equal to 1,000, right? And then what's the next one after that? D is equal to 500. So what we're going to do, right, is we're going to look, is this number smaller than this number? It is, right? So then we're going to subtract this number from this number. So then this number is going to become 2,749. As you can see, we're going to do this 2 more times. So this is going to be 1,749 because we're subtracting this number. And then subtract it 1 more time because this number is bigger than this number. So then we get 749. Our current pointer is right here. And now we compare 1,000 to 749. We see that 1,000 is larger than 749. So we're going to want to shift this pointer to this D. Okay. And we're going to repeat the process. So you see 500, 700. 500 is smaller than this number, so we're going to want to do the subtraction. So it's 249. I think the next number is 100. Yeah. And obviously, as we're doing this, I'm adding on, this is M, 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 D. This is going to be, I think C is equal to 100. So we're going to want to do 149. 49. M, 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 D. I I can see why we stopped using Roman. Now we're at a 4. 4 is where the problems kind of start to okay, this pointer is not here. We're at here, which is 50. And X is 10. So with this, what we're looking here is 40. The way Roman numerals work is that this number is separated by 40 plus 9. So we need to take care of this 40 first, and then we take care of 9, okay? And the way you take care of 40 is you're going to actually want to do the number that's above it, or the number it's at. So you see this 50? 50 minus this 10 right here is 40, okay? So this is a special case, right? So 50 is larger than 79 here, but when it's a 4 or 9, we're going to want to do specific, like a little different, right? So what we're going to do is we're going to want to take this number minus, or this, the current number our pointer's at. In this case, it's L equals 50, and subtract it by the plus 1, which in this case is the X here. So it's going to be 40, obviously, just like we discussed. This is going to be 9. And then the way you'd format it is you just put the X and then the L, right? That's just how Roman numerals work. Okay, so now this is a 2740. Now we just need to take care of this 9 and right. I think after you do that, you need to move the pointer, I believe. Oh, this is not, it's not 9, it's 1. Or no, maybe you just move it no matter what. Hold on. 40, it's bigger. So we do it like that. And for a number like 9, it's XI. Or no, it's... Wait, what is 9 in Roman numerals? Wait, did I forget a 5? Oh, that's why I'm dead ass confused though. V equals 5. I equals 1, dude. So we're at this 9. What's going to happen? The pointer's here. And then we're going to want to look at this one and this one. And when it's a 4, we're here, right? We just want to look at this one and this one. So 4 equals cur plus 1, and 9 is going to equal cur minus 1 and cur plus 1. And the reason we know this is never going to go out of bounds is because both of these numbers will always, like at the lowest case, like for example 4, right? If we only had the number 4, we'd be at this I right here, and then we do this number and then this number, right? Like we would do like the VI. I guess I kind of wrote this flipped, like these should be flipped. And then obviously 9, we would be at this 5. Like we would never be at this I if we had a 9, because 5 is always larger than 9, right? So that's really, really awesome, basically. Can I do this? I don't think that's how that works. I just realized I just wrote some like garbage code. This is like invalid syntax, right? Yeah, okay. Jesus. Yeah, we're gonna want to make these pairs. They could be tuples, I guess. It's not gonna make a difference for this specific example, so we're just not gonna worry about it. How was your day? That was freaking funny. Okay. So while Romans at spot P spot 0 or spot 1 is greater than int num, P plus equals 1. I think we're guaranteed that this is not 0. So that's neat. So I don't even have to worry about any balance checking here. Okay, if C is equal, I guess it's a 4 in this case. Call this cur. No. Okay, if C equals 4, then let's just go back to the drawing. That was cur num equals an str of int of num I guess we have a res too. Like the variable we're going to want to put all the Roman characters in. What was it? It's cur plus 1. Or is it minus 1? Is that what I meant? Yeah. This is supposed to be minus 1. Cur at spot P minus 1. 1 minus cur at spot P 1. And obviously we're going to want to append that, which is the why is it cur? What is this cur? It's Romans. And then res plus equals this one first. And instead of 1, it's 0. And then plus this, which is a 0. And then elif C is equal to 9. I'm going to borrow a lot of this code here, because I think 9 is the minus 1 plus 1. Yeah. So this is plus 1. Plus 1. And then else in every other normal case that isn't a 4 or 9, it's just num equals str of int of num minus Romans at spot P at spot 1, because that's the number, right? Yeah. And res plus equals Romans at spot P spot 0. I'm pretty sure that should be, I should just be able to return res here, and that's just kind of really fun and cool. Wait. Where? Comma, comma, comma. Should be a comma O right here. Int is not in. Oh, I need to make it into a string. I thought it was given to me as a string for some reason. Dude. While Romans. Oh, so wherever I said num, I meant C. Wait, did I? No, I didn't. No. That's not right. Oh, man. Oh, it doesn't save. It's going back up, see? Why not? It's at 3,000, 2,000, 1,000. Now it's back at 2,000. Did I add somewhere on accident? Was this a negative number? Oh, I don't think this is 4. This is while num. This is while num. While int num is greater than 0. Is this num at spot 0 then? What am I doing? This just feels so wrong. I'm just wrong. Why is there an X here? The num is 49. I think I handled this 40 wrong. I put the L, but then I needed to put the I. Wait, what? XL. Oh, did I flip them here? I flipped these too. Wait. Yeah. Okay. This is P minus 1. And this is just P. This is P plus 1. And this is P minus 1. I just flipped them. Nice. Now, the reason it's so slow is because I keep flip-flopping. So I probably need a better way to do this. I really don't like that one, so I'll be right back. Okay, I'm back. I'm going to look at some of the solutions here. Oh, that is a way to do that, isn't it? Can I do the Python version? Yeah, okay, so you got the value. So this is what I did. See, this is interesting. He just hard codes it in. That's low-key cheating, though. Oh. I don't know, bro. That low-key be cheating. Because, oh, I guess it does work for every value. If M is just like legit the biggest one ever, then yeah, I guess that works then. I'm gonna try it. What is it? CD 400, and then he has 90. We need a 9 here. Which is a IX. And then we need a 4 here. Okay. I guess he has it in an array. Can I do 4 P1, P2, and I don't think I can do this. I want to see if you can do this. If they need to be tuples for you to break them apart. Ah, yeah, they need to be tuples. So I guess it does matter that they're not sitting here forever doing this. 1, 2. I don't know, a comma right here. This is so much easier to do in Vim, but I really don't like enabling Vim binds inside Leetcode. I swear they're just not good. Okay, now I can do it. Okay, so it's if num is equal to 0, return, I guess, dot join res. What is this? Num divided by value. Oh, how many? So if it's 3,000 whatever. Oh, that's low-key genius, bro. So this is Roman. So sign val. Right. So for I in range 0 to count, res dot append sign, and then num minus equals val times count. Shit. Maybe I didn't understand it. Where's XL? Where's 40? Do I not have 40 here? No, I don't. Bro. Oh my God, why not? Why not? How is it? How is it? Am I really not? What? Oh, I forgot 900. Ah, man. This is a stupid problem, dude. Now we beat it. Yeah, so this is, I mean, the reason this is better is because it does this multiplication thing. Like if my number is really big, it does, like let's say it's 9,000, it does 9,000, 8,000, 7,000, 6,000. The way this algorithm works, it just goes straight from 9,000 to 0. Like it goes to the next place. Like if it's 9,100, my thing has to do 10 iterations because it's 9, 8, 7, or 9,000, 8,000, 7,000, 6, 5, 4, 3, 2, 1,000. This just goes straight from 9,000 to 0, and then like the 100 that's left over in that example. So yeah, this is why this is way better. And I would not have thought of this. I would not have thought about putting them in here. That's low-key cheating. Okay. All right, what's next? We got maximum number, and that's a largest palindromic number. There's two like there's two premiums in here. So all right, the way, okay, return the largest palindromic integer in the form of a string that can be formed using digits taken from num. It should not contain leading zeros. Yeah, so the way I'm just gonna do this, guys, very simple, is I'm gonna take a look at num here, and I'm gonna count how many of each number there are. So like in this case, there's 4 4s and 2 7s, right? And the way I'm gonna do that is I'm gonna make this array times 10, and every indice is gonna be relative to a number. So the 0th index is the number 0, and the 9th index is the number 9. How many 9s there are? Okay, very simple. So we're just gonna want to do this thing here. Force, we'll do n in r at spot int of n plus equals 1. Very simple, very simple. So now my array is going to be populated with the amounts. And the reason I want to use an array here is just because it's ordered, so I know like the right side is like the bigger numbers and the left side is this, you know, the smallest numbers, and there's only 10 numbers, you know, ever. So or like 10 one numbers, 10 one digit numbers, I guess. If you don't count negatives. Yeah. So now we're gonna go back from this array for I in range, or it's, I guess I don't need to do length of r because it's a set length, but I'm gonna do it anyway. So I think what I'm gonna do is I'm gonna have a, like at the end, I'm gonna join them together. So we got like first half, and then second half. Okay. So if r at spot I is greater than 1, because we need both of them. Yeah, we need both of them. And that's super fun and cool, so... If r at spot I is greater than 1. So I'm gonna take r at spot I, divide it by 2. Gotta put that somewhere probably. So like, let's say there's 3 of them, right? There's 3 9s. 3 divided by 2, integer addition, is gonna give me it's gonna give me 1 because I need to put 1 on each side basically. I'm explaining this so horribly, guys. I've solved this problem before, and like on the interview, I'm obviously gonna go way more in depth. Okay, I don't want no comments. Oh, you gotta explain better. I know. Okay, trust. I'm just chilling right now. You know, let me chill. That's the thing. It's always explain this, explain that, man. Why don't you fuck off? Or no, I'll just say count. First half plus equals str of I times count. I think it's like this. No, it's not. No, it is. Wait. I needed to go after it, though. Oh, so I was right. Jesus, bro. And this one, I need it to be at the end, which is first half. No, I don't. I need it to be... Dude. Am I tripping? So I have 9. I have 9, 9. So I need to put it after this one and before this one. After and before this one. Okay. Second half. Okay. And let me just print just to make sure everything's up to, Yes, I did. I did mean that. Stupid. Nice. if I'm gonna reset them. I guess you can just turn it into, but anyway, I don't know, because let me get a 0. Okay, so for I in range. Bruh. Oh shit. Of course I'm wrong. What am I, stupid? If what a stupid test case, bro. Hilarious. Bro. You guys are really pushing grinding my gears here. Pushing the buttons, as they say. The buttons are being pushed. 7 MS, bro. 7. I probably don't need to go. Like, can I just go to 0 here? What if I do that? That's why. Okay. A few seconds ago. Okay. 28%. Let's see what other people have cooked up. Short counter elegant. Nope. Count dot keys, bro. Dude, what are you writing? Hashmap dot items is value? Bro, what are these people writing? Okay, whenever people whip out the default dictionary, that means they're cheating. Okay? He did the same thing I did with just like way fancier Python technology. All right. Valid Sudoku. Did it yesterday. Really don't want to do it again today. Number of steps, the easiest problem ever. Boundary of it. Okay. I might get one more in, guys. This will be my last one. Just for review here. Cross your fingers that I pass, guys, on some real S. Okay. Let me just make sure I can like solve it. Okay. Let me just read the thing. All right. So get this going. -1, 0. Guys, this is a basic basic backtrack BFS problem. Or is it DFS? It's DFS. You got to be able to solve these ones, okay? You know what I'm saying? Okay, so DFS. What is that, IJ? Is that all you need? I guess in cur total. Or we'll just do total. Or we'll do cur amounts. Okay, simple. Oh yeah, if okay, and then for oh, and then that's why you make them tuples. I get it now. That's why low-key matters. Okay, and then we're gonna need to do if 0 is less than or equal to ni is less than rows, and 0 is less than or equal to nj is less than 2 calls, and that's it. Is that it? Oh, no. And grid at spot ni nj doesn't equal 0. And now we can move in here. Okay. spot equals grid at spots ni and j equals 0 DFS. No, that doesn't work. How do you do it with zeros? Oh, I do it here. No, I need like spot. Wait, where's the backtrack step though? I'm confused. Like I should be removing it or something. Oh, it's grid. Yeah, this doesn't feel right. What? How is it 0 or null? So I think it's up here. How is it null, bro? Oh. Oops. Ah, man. Is it in here? Nah, that doesn't make sense. You added after. Yeah. And it's not in here, right? Nope. 28. It's really not. Current amount plus spot. Temp equals graded spot IJ. How do you even get 17, dude? 6, 8, 14. Bro, what? 987. Just make sure it's not like bugged. Am I not backtracking? That's not gonna do anything. I don't understand, like. Wait, how is the current amount 8, bro? Oh. Oh. Oh, I'm an idiot. Oh, okay. Now we get it. Stupid problem. God, bro. You're killing me. All right. Well, I'm probably gonna be back. I might work on the project a little bit. I'm not sure yet. But I think I reviewed like what 3 problems, and I did Leetcode of the day. That Leetcode of the day was so easy. Um. Yeah. So we were back, or peace. I don't know.